Hi, and welcome to the Public Gardens GIS training series. I'm Brian Morgan. In this 7-part series, we're going to walk you through the process of creating a GIS for your garden using the ArcGIS Public Gardens data model. In this opening lesson, we will introduce you to some of the resources of the Alliance for Public Gardens GIS, and we'll show you a bit about GIS data models. Let's get started.
So I'd like to start off this first lesson in our Public Garden GIS training series with a little introduction to the Alliance for Public Gardens GIS and what we do. The Alliance is a group of collection managers and GIS users from botanical gardens, arboreta, parks, zoos, and other managed landscapes, even campuses, from around the country and the world. And we're working together to make GIS more accessible to public gardens by providing software such as the ArcGIS Public Gardens Data Model and Collection Researcher, services such as help us getting started with your GIS project, technical support if you have questions about your GIS project. We have a user community out there, which I'll talk about in just a little bit. And we do training events and other training services such as this video series. And we like to promote the use of GIS for asset management, conservation, education, and research. We feel that GIS is really a great tool for meeting multiple goals inside the garden, and yeah, we like to get that out there to the garden community. And we provide resources for getting started with GIS or using one more effectively. So whether you're just starting a new GIS project and you have questions and need help as far as what to do and where to start, we can help with that. And if you already have a GIS and maybe you want to upgrade it and start using it more efficiently or start using it for things other than managing your plant collection, we are here to help. We have a website at apgg.org that has a lot of the resources that we have created there, and lots of information about different things that are going on in the GIS / public gardens community. We've experimented with several different social networking models, and we found that LinkedIn is the preferred format by many of our users. Our LinkedIn group has well over 300 members and is quickly growing, and it's the preferred spot to go for getting news about what we're up to and what else is going on in the community, for asking questions, having a discussion with other members of the community, and getting technical support. So if you had a question about a particular technical problem, we ask that you post that question in our LinkedIn group. That way the answer is out there to benefit other members of the community. We also have a Twitter, Facebook, and Google Plus social networking pages / accounts that you can subscribe to depending on what your preferred social networking environment is, and we pretty much post the same information on all those things. So anytime we have a news article that comes out, we'll put it on Twitter, put it on Facebook, put it on Google+. And additionally, we have an RSS feed that you can subscribe to if that's your preferred format for getting electronic news. We have a YouTube channel that you likely found these videos on, that we are continuing to add video content to all the time, whether it's content that we produce or it's content from other people that we think is really applicable to the public garden community. We'll post that on there. And additionally, we have an ArcGIS Online group that we invite you to join, that we are encouraging people to share their GIS maps, their GIS data, any applications they might develop, all that kind of stuff. All the GIS related materials we can post on there and share with the rest of our community. I'd like to talk about the ArcGIS for Public Gardens program that we have developed with Esri. Esri has this new program that is in place for the next 3 years, and it provides software training and support and conference registration to any member of the American Public Gardens Association. And it's $100 to apply for this, and you can pretty much request, whatever software or books or training materials you would like for Esri, and they're generally really flexible about providing those. The standard grant program provides 1 license of ArcGIS for desktop, 1 license of ArcPad, and a membership or subscription to ArcGIS Online, which will let you create a kind of GIS portal, if you will, for your organization. So you could have a customized kind of website where you host your online maps and things like that, all available through ArcGIS Online. The program also provides unlimited online training, and Esri has quite an extensive list of courses available. Additionally, you can request standby live training, so they teach instructor-led courses, and if those courses aren't full, you can sneak into those and take those for free, which is an incredible value. And then also books. There's a couple books that are available that come as standard as part of the program, and you can request additional books if you'd like. So the grant program gives you 3 years of software maintenance and support, and you can renew that and apply for the grant again after those 3 years. And additionally, you're eligible for free registration to Esri's International User Conference, which is in San Diego every summer, and that is also an incredible value and a great place to meet other GIS professionals, even GIS professionals from the public garden community, and learn just an amazing amount of information about GIS and how to better use it at your garden. To apply for the program, we encourage you to send an email to Angela Lee at alee@esri.com, and first, actually, look on the APGG website under grants, and you'll find more information about the grant program, a downloadable kind of summary, and then once you've looked at that, send an email to Angela Lee, and she'll get you set up. And now I'd like to talk a little bit about the grant program that we've been working on at the UC Davis Arboretum. We have a grant from the Institute of Museum and Library Services to develop a GIS training program for museum professionals, which this video series is part of those grant deliverables. And this grant has helped us to develop the Alliance for Public Gardens GIS website, helped us to put all these social networking sites in place that I was just talking about. We've been developing some making the case materials that are designed at kind of making the case, as the name implies, to your director or whoever holds the purse strings at your institution, to convince them that GIS is a right choice and a worthy investment. So those materials we'll have available on our website as soon as we are finished producing them. We're also producing a guide to GIS book, and that will be available online as well. And that guide kind of walks you step by step through the process of creating a GIS, all the way from the is GIS right for your garden question, to getting funding, to actually creating the GIS, and all the way to publishing maps in print and on the web. We're also putting together a model volunteer program, and that program is designed to help gardens recruit volunteers to assist them with their GIS project. So we realize, many gardens don't have the staff time and resources to be able to develop their GIS, and this model volunteer program will help you to recruit and train your volunteers to get your GIS project done. Additionally, we are designing a professional services program that's geared towards connecting gardens with GIS professionals who may want to volunteer. Um, Sometimes, GIS professionals maybe not have may have some extra time. They don't have a full-time job, or they're out of work at the moment, or maybe they're retired, and they are a lot of times looking to donate their skills and volunteer in the community. And this professional services program is designed to link those people up with you, so that you can bring in these GIS professionals to help you with your project and get really top-notch GIS people to help you, hopefully at no charge. And another deliverable is our training videos. You're watching this series right now, and we're planning on producing additional videos, and those will all be available on our YouTube site. We also have been doing a series of training workshops, and we plan to continue these workshops. And they're a great opportunity to be able to get instructor-led training, and currently we offer a single workshop that is geared towards helping people get started with GIS, and it's a full-day workshop. So stay tuned. You can find out more information about those websites by staying connected with our news through one of our social networking groups, or looking at our event calendar online. Okay, I'd like to switch gears now and talk a little bit about the ArcGIS Public Gardens data model and data models in general, to give you a little background about what we're going to be working with in the series to help build the GIS. Some years ago, we received at UC Davis a grant from Institute of Museum and Library Services to help us design a data model for the public garden community. And we started that project with the idea of this graphic that we're looking at here. It's just called Enterprise GIS. And the general idea is that you use GIS for more than one function. A lot of people get into the GIS world at public gardens because they want to map their plant collections, but there's so much more that you can do with GIS, and we wanted to be able to design a data model, or template, if you will, that allows people at botanical gardens to be able to do all sorts of different activities with their GIS. So if we consider our plants our assets, or our primary asset at a botanic garden, that was, of course, one of the main functions we wanted to include, is to be able to manage those assets with the GIS. But you can also consider your benches out in the landscape and as an asset, your dedication features, cultural resources, all sorts of different things that you have out in the landscape can all be considered assets. So we wanted to be able to manage those with the GIS. But since gardens are typically, public places, we generally have to have emergency response procedures in. And with the GIS, you can, do things such as, create evacuation plans and whatnot with the GIS. So we wanted to include the capacity to do that kind of stuff. New projects, say you're redeveloping a part of the garden and you want to manage that project. You want to track what's going in, track what's coming out, things like that. You can do all that with the GIS. Customer service, in the public garden world, our visitors are our customers, and we want to be able to serve them, so we can use the GIS to be able to produce things like visitor maps, guided tours, things like that. We can do all that sort of thing, all those sorts of things, with the GIS. Engineering, for designing something new, we can have exact, precise measurements that come out of the GPS that you can supply to designers and whatnot. Mobile, you can take anything that you see on your desktop out in the field with you. So whether that's collecting data while you're out in the field on the locations of your assets, or just being able to pull that information up while you're out in the field, GIS will allow you to do that. Logistics, work order management, code compliance, all sorts of things that you can do. Work order management is a particularly interesting one, that you could have somebody out checking out the grounds after a storm, finds a dead branch down. They can pull up, something on their mobile device that show and put the location of where that down tree is into their mobile device, which can trigger a work order to the grounds crew that needs to come out and take care of that. So lots of neat stuff that you can do with that. Site selection, finding the best spot for something. Say you get a exotic plant in that doesn't necessarily isn't really well suited to your climate, but it can be grown if it has the right conditions, and maybe you need to know where the moist soils are that are in a kind of a cooler microclimate of your garden. If you've collected data on that sort of thing, if you have soils data, if you have weather station data, and even like aspect data that shows how the sun is going to be hitting a particular area, you can use all those things to model or kind of predict where the best spot would be for a particular plant. So it's another great use of GIS. So lots of stuff you can do with GIS, and this is what we're going for with the design of the data models, to allow you to do all these different sorts of things with the GIS. So you've heard me say data model quite a few times now, and almost everybody's question at this point is, what exactly is a data model? Well, the official definition is that a data model is a description of the rules by which data is defined, organized, queried, and updated within an information system. It can be more simply thought of as a database schema, and schema just kind of means the tables that are in a database, the fields that are in those tables, and maybe the relationship between different tables and fields. There are currently over 30 different data models in existence for ArcGIS, and this is just another one in that series. And those models range from, there's ones out there for biodiversity conservation, there is one for forestry, there is another one for, the oil pipeline industry. So all sorts of different things out there that you can do with GIS, and these data models provide a practical template or starting point for implementing GIS projects, so that you can download this template, and instead of having to reinvent the wheel as far as how to store your information and what attributes to record about a particular object like a tree, we've already done all that work for you and created relationships between things, so that a planting bed has a relationship with the plants that are in it, so that you can click on the planting bed and quickly get a list of all the plants that are inside that. So we've done all that work ahead of time so that you don't have to, and that's what the beauty of a data model is, that it lets you get started mapping really quickly. So the goals of our IMLS funded project were to create a free and open source template with documentation for getting started with GIS at Public Gardens. And we wanted to make it so that the smallest garden and the largest garden could both use it equally well. So we worked with this idea of light, medium, and extra strength, so that if you just want to map your plants with it, fine, just use that piece of it. But if you want to map things like people movers and different stops along tours, all sorts of different things, we have the capacity to do that within the data model. And because modeling a botanical garden is a big project, we tried to focus on the features that would provide the greatest benefit to the garden community and that people were going to use the most. So we may not have everything excuse me, in your in the data model that you might want to map, but the majority of what you're going to need is going to be in there. And we're always happy to work with you to design something custom that for you that can also be used by the rest of the community. And another premise is that we wanted to make the data model work with existing plant record systems. We know that the majority of gardens already have a plant record system like BGBase or something in Microsoft Access or FileMaker that they're really tied to. And we wanted to make sure that the data model would work with those systems in the capacity that you can pull in information from those plant record systems linked to the dot that's on your map, and try not to replace them, so that it wasn't asking people to make a huge change to be able to start using it. So designing the data model was kind of an exercise similar to trying to model an entire city. Gardens typically have much of the same level of complexity that a whole city has. So we have utility networks, we have roads, we have buildings, all those sorts of things we needed to include. So it's fairly complex and comprehensive once we gotten going with the project. Our community survey that we did at the beginning of the project indicated that plant records, of course, was the most important thing, so the ability to map plants. And then base map information, such as kind of the background to a map. So if you think of your maybe a plant collection map, you would probably have the locations of buildings and roads and things like that. All that information came back as being really important. And then facilities and infrastructure, so the ability to map and manage those sorts of things, came back as being the most important features to have in the data model. So we focused on those pieces when we were designing it, and created a base map and facilities infrastructure foundation with a basic plant collections module. And when I mean basic is that it does not replicate the full functionality in many plant records databases, but if you were a garden who was just starting to map and track their collections and you didn't have a plant record system in place, you could use the data model as a standalone plant record system, even though it is relatively simple and basic in the amount of information that it includes. There are currently over 100 different objects in the model, and when I say objects, I mean different sorts of information that you can map or track in the model, so it's fairly comprehensive. Before we get more involved with the data model itself, it's important to know about some of the terminology that's used when talking about different parts or objects inside the data model. The most important one to consider is what's called a feature class. And in the diagram on the right here, it is a feature class is in blue. And feature classes are generally point, line, polygon, or annotation being text labeling. And so a point feature class might store the locations of plants and symbolize those with a point. A line feature class you might use for something like fences because they're linear, and they'll draw as a line on the screen. And then a polygon feature class you might use for something like a planting bed. We would draw a line around the outside of it, but that line closes and thus forms a polygon. That is the boundary of that planting bed. And then annotation, as I mentioned, would be used for maybe storing the scientific name and accession number of a plant that you want to display on your map. And those are fixed labels, so that when you pan and zoom around your map, those labels stay the same size and in the same place. Another object that's inside the geodatabase is a table. Tables are also shown in blue in the lower right-hand part of that diagram, the right. And tables are very similar to feature classes in that they store information in rows and columns and have different fields. And the main difference here is that a table doesn't have any geometry associated with it. So a table would be used maybe to store a list of contact information that may be associated with different things in the database or things like that. And there's no points or lines or polygons on the map with that table. Another object in the geodatabase is a raster. A raster is like an image. It's made up of multiple pixels that usually when you zoom out so you can't see the individual pictures, those pixels form an image such as an aerial photograph. And that's the most common type of raster that we'll be working with in the geodatabase. So you may get an aerial photograph from maybe your local government or something like that, and you can store that right inside the geodatabase so that when you want to move things around, your imagery goes with it. Another important object is the relationship class, and those are symbolized in green in the diagram at the right. And relationships are between two different feature classes, or a feature class and a table, or two different tables. And they can come in several different varieties, but I'll give you an example first. A mass planting, or a group of plants that we have out in the garden. So say we have a group of plants that are too complex or dynamic to map as individuals. So maybe it's 3 species of wildflower that always come up in the same bed, but they may come up in totally different spots every year. And you just want to kind of draw a line around them and say that this polygon that I just drew, or it contains 3 different species of plant. And I'm not totally concerned where those species are on a year-to-year basis, but I just want to know that those 3 plants are in there. So in the data model, we have something set up as that a mass planting, when you draw it in on the map, it can have 1 or more plants associated with it. And this way you can have those 3 different species associated with it as points that lie inside of that polygon arbitrarily. And they're related so that when you click on the mass planting, you can see that there's those 3 species in there. And we'll look a little bit more at that in some of our other lessons. But relationship classes are just a way to connect information and show that there's some real-world relationship that we're trying to capture in the modeling of in the geodatabase. Another important object is a topology, and a topology is a set of rules that kind of governs the geometry of objects on the map. So we have a bunch of rules that we've defined in the data model that say that buildings and, for example, buildings and water should not overlap. So if you have maybe done a little bit of a sloppy job drawing things in on your map, and your building kind of overlaps a water feature, it will throw up an error. And this error you can deal with accordingly. If in fact your building does go over the water, it's built out that way, you can say that that's an exception to that rule and you'll let that go. But what these rules do is they help you to see where you've done a poor job of drawing things, or where you violated some rule. So they can be really helpful for quickly identifying and correcting errors that are making your data of poor quality. Another important part of the data model is what's called a subtype, and under each of or many of the blue feature classes or tables, you'll see there's a light blue piece, and I realize you can't read those. We'll look at those in a little bit more detail, but those are where we're recording information about subtypes. So each feature class or table can have a subtype with it. So in the case of a plant center, we can have our plant can be of 1 of 2 different types. It can be an individual plant that is standalone, like a tree, or it can be part of a mass planting. And we have 2 different subtypes, one for the individual, one for the mass. And each subtype can have different rules and attribute rules associated with them, and we'll look at those in more detail. Another example, though, is that we say buildings. We can have different subtypes of buildings. So a building may be based on use. So a building may be an administrative building. It could be a research building. It could be an exhibit building, or it could be mixed use. And we have those designated as subtypes, and you'll see a little bit more of those as we explore and work with the data model. Finally, the last object on our list here is a domain, and domain is a list of valid values that can go in a particular field. So perhaps when you're out collecting data, You want to have a drop-down list to make your data collection go a little bit easier. And that drop-down list maybe contains all of your accession numbers. Or it could be a drop-down list of the growth habits of different plants, which we actually have built into the data model. And that means that the plant habit field for our plants has a list of values. It can be, a plant could be a tree, could be a shrub, could be a subshrub, could be a vine, etc. So you get the idea. And these domains make it easy to also find data errors. You can validate your data, and if if you have a value entered in a field that doesn't appear in your list, it will show as an error. So maybe you typed something in poorly or didn't select it from the list, which is always an option. You can quickly find and identify those errors. I think the one more thing to talk about here, and I've mentioned it a couple times, is what's called an attribute, and you'll hear this word a lot. An attribute is just a field. For instance, we're going to stay on the subject of plants. Our plants have multiple fields associated with them, and I just mentioned the plant habit and the accession number fields. Those are also called attributes, so don't be frightened by that word. But it actually makes quite a bit of sense, is that if you're trying to map and model some object out in your landscape like a plant, you want to know the attributes of it. You want to know information about it. You might want to know the DBH, things like that. All that information we have tried to pre-design for you, so hopefully you won't have to create too many attributes, but if you need to, we'll go over that a little bit as well. So this is a poster that we have available for the data model, and I realize that you're not going to be able to read this, but I wanted to show you, this is a little kind of view under the hood of the complexity of the data model. On the left, we're looking at the overall structure of the geodatabase. So in blue, we've got our feature classes. In green, we've got our relationship classes, etc. And then to the right, or in the center, we've got our kind of schema level view. So we've zoomed in to some of these feature classes and relationships. So feature classes are still in blue, and this is showing you a list of all the different fields or attributes within the feature class. Green are relationships between feature classes, so you can see green lines go from one feature class to another. And then red are some of those domains that we've talked about, and the domains are those lists of valid values, and those are associated with particular fields in there. So you can see that this field, for instance, may only have this list of values associated with it. So you can download this poster with the data model from the APGG website and use it as a technical reference if you need to while you're working with it. So let's talk a little bit more about structure. So if we're out looking into the data model, and I want to give you some examples of how relationships work. So one of the feature classes we have in the model is called section, and the section feature class is used to define smaller administrative boundaries for a garden or thematic area. So for instance, at the UC Davis Arboretum, we have our garden divided into sections based on kind of what sort of plants we have in there, or what type of garden it is. So for instance, we have a California native garden. That is one section of our garden. We have a Mediterranean climate part of our garden. That's another section. We have an Australian section that's just Australian plants. And most gardens have these type of things, and it's I'm sure that you have some of your own. And you can use this feature class to delineate those section boundaries at your garden. And under section, you'll see a relationship class here that says section has structures, and you'll see that it says one to many. And what this means is that one section may have 0 or many different structures associated with it, so that when you click on the section in your GIS, you'll be able to see what buildings are in there really quick. And the structures feature class you'll see here to the right of the relationship in blue is used to store the footprints of buildings or structures. And it has subtypes. So as I mentioned earlier, you can have an administrative building, an education focused building, exhibits, facilities building, research, visitor amenities, mixed use, or other types of structures. And each one of these structures then has more relationships. So in this case here, we have structure has enclosures as the next relationship under it. So that means that a structure may have one or many or none animal enclosures associated with it. So in the case of a zoo, a building, if it's a exhibit building, that's a exhibit subtype from the structure feature class, it may have multiple enclosures for each one of those animals in there. And now we're not actually drawing in those enclosures because we're not really, the GIS at this point, we're not concerned as much what's inside of a building as far as where those things are, but more just knowing that it exists. So in this case, instead of drawing the animal enclosures in, we're just providing a list of those animal enclosures for management purposes. So therefore, instead of using a feature class, we have that data stored in a table because it doesn't draw on the map. In this case, our animal enclosures has subtypes as well. It can be an amphibian animal enclosure, bird, insect, fish, mammal, plant, reptile, or other. So those things are all mapped in there. You'll also see that a structure has another relationship under it. It says structure has entrance and exits. And this is also a one-to-many relationship, meaning that a structure can have zero or one or many exits and entrances associated with it. And these are really handy for doing routing. So once you've identified the entrances and exits to buildings and the entrances and exits to your property, and any other entrances and exits through any barriers that you may have on your property, you can then route people from point A to point B and produce things like visitor maps and emergency management maps and things like that. So you'll see here that our entrance and exit feature class is mapped using points. So we just draw those points on the map of where those entrances and exits are, and they can be of subtypes are barrier or fences. You can have an entrance and exit to a people mover, to your property and structures, as we mentioned, and then to any restricted areas you might have in your property. So all kinds of stuff you can do with the GIS. So if we zoom in a little bit and look at the structure feature class in more detail, now we're on the schema level that we looked at a little bit in the poster. And now you'll see a little bit more information about this. So our structure says it's a polygon simple feature class at the top, and it shows a list of all the fields or attributes that we have for this feature class. So if we look down the left-hand side of this little diagram here, we'll see that there is a structure ID, which is a unique ID that we assign to each of our buildings or structures. We have a type field that is used excuse me, to store the subtypes values, whether it's an administrative building or an educational building, etc. Our building has a name, or can have a name, can have an address, a construction date, life expectancy, a link to any construction documents you might have for that building. So if you have blueprints, you can link those in there so that when you click on the building on the map, you can quickly open up the blueprints for that building if you'd like. We track how many levels are in a building, the presence or absence of utilities like water, gas, telephone, data, sanitary sewer, storm sewer, etc., heating, cooling, fire suppression, security, all that stuff's all in there. Whether this building is ADA accessible, and things like that. And you'll see that for these utility attributes here, like utility water, utility gas, if you look over to the right, you'll see under the domain column that yes, no is the domain associated to these fields or attributes. And if you look over on the right, you'll see the actual domain that goes along with that particular that field, the yes, no domain, and it has two values associated with it, yes or no. So that means that when you're entering data in that field, the only thing you can enter is yes or no. That makes data entry really easy and clean, and assures that you're going to have good quality data. You'll also see that we have some relationship classes detailed here in green, and you can see a little bit more detail about those relationship classes, such as what is the field that's kind of makes the link between those two. So in this one here, where structure has enclosures, you'll see on the left here that it says primary key is enclosure code. And the foreign key is enclosure code. And if you look on the left, you'll see a field that says enclosure code. And what this means is that if you enter, say, the number 1 in a field for enclosure code, and you enter that same value in the enclosures table, those things will be linked together, so that then you will be able to see that your structure has an enclosure associated with it. And we'll work with relationship classes more in some of our other lessons. So now that we've given you a little bit of background about the Alliance for Public Gardens GIS and our training grant and the GIS data model, I want to talk a little bit about the remainder of this series. So we've organized the GIS training series into a series of lessons, and each lesson covers a step in the process of creating Public Gardens GIS. We assume that you have basic knowledge of ArcGIS, equivalent to the Esri course Learning ArcGIS for Desktop. If you go to Esri's website and go to their training section, you can look at this Learning ArcGIS for Desktop course and make sure that you have that knowledge, level of knowledge, before proceeding with this GIS training series. I will be very diligent about providing all the steps as we go along. So if you feel that you're really comfortable with learning new technology, you might do fine in the course without taking this Learning ArcGIS for Desktop course. But if you're new to GIS and you're not maybe technically prone, I would recommend taking this Learning ArcGIS for Desktop course before continuing on with our series here. Everything in our training series is performed with ArcGIS 10. I've tried to make comments as much as possible for people who might still be using ArcGIS 9. And the workflow in ArcGIS 10 is very similar to the latest version, 10.1, so we think that hopefully this series will be applicable to just about everybody, no matter which software product they're using. We do some field data collection in the course or in the series, and we use Trimble hardware and software to perform these steps. We realize that many gardens may use other GPS data collection equipment and different software products, but we've come to find out that the majority of gardens seem to use the Trimble products, so therefore we've been using those in this series. The general skills and procedures are going to be applicable to other hardware manufacturers and software manufacturers' products, but again, they are focused on the Trimble specific products. And I think that's just about it. That'll wrap up this episode. Please check out Lesson 2 if you think that your skills are ready to go, and we'll see you next time. Thanks.